This video is going to cover part 3 and part 4 of the June 2019 Geometry Regents. First up, we have the part 3 questions. These are 4 points each. So for 32, Riley plots these 4 points to form a quadrilateral. We want to prove that it's a trapezoid. It says the use of the set of axes on the next page is optional. I have already gone ahead and plotted that shape. I always graph when it says it's optional. I think it's helpful to look at, because what we know is that about a trapezoid is that at least one pair of the opposite sides are parallel. And if I look at the picture, it helps me decide which sides are going to be those parallel sides. So to me, it looks like AD and BC are the parallel sides. Now I just have to prove that. So I'm going to find the slope of AD and find the slope of BC. So when you have parallel lines, their slopes are going to be equal. So for AD, change in Y over the change in X, that has a slope of -3. You could use rise over run on the graph too. That's perfectly fine. BC, I get -9/3 or -3. Those slopes are the same. So I'm going to write this in a little bit of like a long sentence here. So I'm going to say, since the slopes of AD and BC are equal, any type of proof, by the way, you need to write a sentence. So since they're equal, I know that AD is parallel to BC. Since a trapezoid has at least one pair of opposite sides that are parallel, ABCD must be a trapezoid. Now there's a second part to this question. It says, Riley defines an isosceles trapezoid as one with congruent diagonals. Use this definition to prove that ABCD is not an isosceles trapezoid. Okay, so look at the diagonals. The diagonals are BD and AC. We want them to not be congruent. This is not asking us, are they congruent? It's saying it should not be. So we just need to prove that. So what I'm going to do to show that things are not congruent is use the distance formula. So I'm going to find the length of AC and I'm going to find the length of BD. So the distance formula is this big radical where you subtract the x's and subtract the y's and square each of those values and then add them up. All right, so let's look at AC here. I'm going to scroll back to my coordinates. If I subtract the x's, so I'm looking at A and C. When I subtract the x's, I get 7. When I subtract the y's, I also get 7. Doesn't matter what order you subtract them in. So if you got -7, that's fine. We'll get the same answer in the end. That's going to give me radical 98. If I look at BD, so now I'm going to look at 3, 8, and 1, 0. When I subtract the x's, I get 2. When I subtract the y's, I get 8. So that's going to give me 4 plus 64, or radical 68. Those are obviously not equal. So I'm going to say, since AC does not equal BD, ABCD is not an isosceles trapezoid. Okay, and that concludes this question. 33. A child-sized swimming pool can be modeled by a cylinder. The pool has a diameter of 6.5 feet and a height of 12 inches. Let's automatically change that. There's always these tricks on here. We want this to be 1 foot, right? We want these units to match. The pool is filled with water 2/3 of its height. And we're going to determine and state the volume of water in the pool to the nearest cubic foot. Whatever unit it says at the end of the problem, that's the unit you want. So that's how I also know to get rid of the inches. All right, a cylinder. The formula for volume of a cylinder is on your reference sheet. It's pi r squared h. The radius is going to be 3.25 if the diameter is 6.5. The height is 1, but we only want it filled 2/3 as high, so 2/3 of 1 is just 2/3. And we're going to find this to the nearest cubic foot. So let's put this all in our calculator, just like this. And so the volume of water in the pool is 22 cubic feet. Then it says 1 cubic foot equals 7.48 gallons of water. Determine and state that to the nearest gallon the number of gallons of water in the pool. So we basically just are converting units here. So what I like to do for this question is take the value that we know, so in this case the 22 cubic feet, and put it over 1. So this is like our known fact. And then this is our like given fact in the problem. We are given that 1 cubic foot equals 7.48 gallons. So I have to insert those two pieces of information into this fraction, but I have to do it strategically. I need to put the cubic feet on the bottom so that these cubic feet will essentially cancel out, because it's cubic feet over cubic feet, which is 1. Anything over itself is 1. Because I want the answer to just be gallons. Now I'm going to multiply, so 22 times 7.48. We're looking to the nearest gallon, so this is going to give me 165 gallons. Just a note, when you're doing a question like this and there's two parts, notice how I used my rounded answer of 22. You're just going to carry over that answer. Let's say you had no idea how to do the first part, or let's say you did the first part wrong. You didn't notice the units were mismatched, for instance. Whatever answer you get, as long as you use it correctly in this bottom part, you won't lose points twice for that same mistake. 34. Nick wanted to determine the length of one blade of the windmill pictured below. He stood at a point 440 feet on the ground from the windmill's base. Using surveyor's tools, he measured the angle between the ground and the highest point by the top blade and found it was 38.8. He also measured the angle between the ground and the lowest point of the blade, found it was 30. Determine and state the blade's length to the nearest foot. This is what I call a double trig question. So I'm going to draw the two right triangles that were given here. So there's the big one where this is 38.8. And there's the slightly smaller one where this is 30 and 440 on the bottom. But I'm going to add in a few other elements. I'm going to call this side y. So y is the height of the smaller triangle. And I'm going to call the height of the big triangle z. So I'm going to introduce two additional variables. But the key is, if you look at that picture, x is the difference between z and y. That's our key to getting this answer correct. The other hint I will give you is that on these double trig questions, they are almost always tangent questions. Right? It is possible for it to be sine or cosine, but really extremely often it's tangent. So I'm going to set up two SOHCAHTOA equations. So tangent of 38.8 is equal to z over 440. I'm going to cross multiply that. So 440 tangent 38.8, and z is 353. And I'm going to copy down all of these decimals. It's asking me to round the value of x. This is not x, so I'm not going to round it. Over here, this is tangent of 30 is equal to y over 440. Cross multiply, you can put those over 1 if you don't see the cross multiplication. So 440 tangent of 30 is 254 in all of these decimals. And remember, we said x is equal to z minus y. So I'm going to subtract those two answers. I'm just highlighting them in my calculator so I don't have to type them in myself. And we're going to round to the nearest foot. In that case, that means the nearest whole number. So I'm going to get 100 feet as my answer to this question. Okay, for the last question on this exam, we have a proof. And we want to decide right off the bat if this is going to be a similar triangle proof or a congruent triangle proof, because that will give us better direction as to where to go. This is definitely a similar triangle proof. If you look at the triangles, they're not the same size. So I'm going to be using the goal of getting the triangles similar, and the way to do that is using angle, angle. I have already gone ahead in this problem, set up my, I'm gonna actually get the calculator out of the way. I have set up my statement reason columns. I have copied all of my givens over, and I've marked the diagram. So I know that HM and AT are congruent. I know HT and AM are congruent. I also know I have some perpendicular lines, which forms right angles. I'm gonna talk about that in the proof though. We have to still mention it. And our goal is to prove the product of two segments is equal to the product of two other segments. Okay. All right, so let's work with the givens. Once you write the givens, see if you can elaborate on them. I know that if HM and AT are congruent and HT and AM are congruent, that we have a parallelogram here. So I'm going to say for line 2 that math is a parallelogram. The reason is always, well, how do you know that? And I'm going to say a parallelogram is a quadrilateral where opposite sides are congruent. So I mentioned before that when you know you have similar triangles, you're looking for angle, angle. So you have to think, well, how does this parallelogram fact help us decide anything about angles being congruent? Well, I know that angle M and angle T must be congruent now, because, like, think about a parallelogram for a second without all this stuff going on. They're opposite angles in a parallelogram. So I'm going to say for reason 3, opposite angles in a parallelogram are congruent. Okay, then I mentioned before that we have perpendicular lines here, and we need to talk about those right angles. I'm going to pick the ones that are in the triangles. So I'm going to say angle HEM and angle HAT are right angles. I know that because perpendicular lines form right angles. And remember, the goal is always to get them congruent to one another. So I'm going to now say those angles are congruent. And I know that because all right angles are congruent to each other. They're all 90. So now if I look at these two triangles, I'm actually going to take out these tick marks just to make this picture a little simpler here. You can see in this triangle, I have two angles marked off. In this triangle, I have two angles marked off. So those two triangles are now going to be, we're able to prove them similar by angle, angle. So for line 6, I'm going to zoom out for a second here. I have that triangle HEM is similar, notice the symbol there, to triangle HAT. And that's by angle, angle similarity theorem. So when you are given the proof, I mentioned before, the first thing you want to decide, is it going to be a congruent triangle proof or similar triangle proof? I would make that decision and try and reach that goal. And if we can go further and we can get to the proof statement and get all 6 points, great. But we definitely need to at least prove something about the triangles in these proofs. Like, that is going to be key and your first way to ensure that you're going to earn a good amount of points on the question. Okay, so we're definitely getting a lot of points here for showing that the triangles are similar to each other. Now we have to think about, how can I possibly prove that those two segments, the product of two segments is going to be equal to the product of the other two segments? Anytime I see that, I know the proof is going to have 2 more lines. So I'm going to do this in kind of a weird order here. I'm going to take the proof statement, which says TA times HA. Sorry, I'm scrolling back and forth, is equal to HE times TH. And I'm going to put that for the proof. Okay, so I'm telling you that if it's similar triangles and the proof statement is about these products being equal, you have 2 more lines to go. The reason I fill that in is to help me fill in line 7. I kind of work backwards. When you have similar triangles, yes, the angles are congruent, the corresponding angles, but the corresponding sides are proportional. If they're proportional, that means you can write a proportion with them. So I'm going to take this and I'm going to fill in this proportion with those 4 segments. And you might say, well, how do I know how to fill it in? Look at this first diagonal here. TA and HA would get multiplied. And look what we have here, TA times HA. When I multiply this diagonal, I would get HE times TH. Look what I have here. So I'm just kind of like undoing the cross multiplication, basically. Okay, here's what I'm going to fill in for those reasons. How did I know to write that proportion? Well, that's because corresponding sides in similar triangles are proportional. And you can also abbreviate that. I let my students abbreviate it CSSTP. Corresponding sides of similar triangles are proportional. Then we have to explain, well, why are those products equal? That's because cross products, that's what it's called when you cross multiply. So cross products of proportions are equal. And we have now completed the proof and this entire Regents exam. Be sure to check out other videos on my page to see solutions to other Geometry Regents exams.